Hello, I'm Edward Tarte. This is another in a series of solution videos for some of my math challenges. The challenge for this solution video is my Special Twins challenge. And here is how I presented that challenge in the original video. This challenge concerns what I call birthday twins. By that I mean a pair of people who have the same birthday. Not necessarily that they were born in the same year, but that they celebrate the same day of the year as their birthday. Please assume in this challenge something that is not really true, that there is no such thing as a leap year, that every year has exactly 365 days. That will make the challenge much more user-friendly, and the result will be only a tiny bit away from the real truth. Imagine a group of people. First, imagine just two people chosen at random. What is the probability that those two people are birthday twins? The probability is very slight, only one chance out of 365, which is less than 1% probability. But if you have a larger group of people, the probability that there is at least one pair of birthday twins will increase. If you had 400 people in the group, there would certainly be at least one, in fact, many pairs of birthday twins. So the probability can range from almost 0% to 100%, depending on how many people you have. My challenge to you is, what is the smallest number of people in a group such that the probability that there is at least one pair of birthday twins is greater than exactly 50% probability? The fact is that occurs sooner in the process of filling the room than many of us, including me, might think. But my second question is, what is that probability that is barely above 50% to the nearest thousandth of a percent? You'll obviously need a calculator to work this challenge. The only way I know to solve this challenge is to figure out the probability of birthday twins not happening and then subtract that probability from 1 to find the probability that birthday twins will happen. For example, if the probability of something is 1/4, the probability of it not happening is 1 minus 1/4, which is 3/4. We begin with two people, the simplest example. If there are two people, the first one has a specific birthday. There are 364 chances out of 365 that the second person will not have the same birthday. And so the probability of birthday twins is 1 minus that fraction, which is a decimal less than 1%. It's 273 thousandths of a percent. If this is occurring in a room and a third person arrives in the room, that third person has 363 ways out of 365 of not matching up with either of the first two. And so we have 1 minus those two fractions multiplied. That gives a probability percent that is still less than 1%. Notice, for three persons, we have two fraction multipliers. If a fourth person enters the room, still assuming there are no birthday twins, that fourth person has 362 ways out of 365 of not matching up with any of the other three. And so we have 1 minus the product of those three fractions, giving 1 and 636 thousandths percent. notice that for 4 persons, we have 3 fraction multipliers. We are now aware of the pattern of the fraction multipliers. The numerators decrease one at a time. The denominators remain 365. So we continue 1 person at a time. When we get to 12 persons, we have 1 minus the product of 11 fraction multipliers, and that gives us over 16% probability. When we get to 22 persons, we have 1 minus 21 fraction multipliers, and that gives us over 47.5% probability that there will be at least 1 pair of birthday twins. Now, 1 more person enters the room, a 23rd person. We have 1 minus 22 fraction multipliers, which gives us a probability of 50.730%. That is over 50%. That means that the smallest number of people that yields a probability of over 50% that there will be at least 1 pair of birthday twins is 23 people. Far fewer people than many of us, including me, would expect. Of course, I've been doing this on my calculator. I wrote a program on my calculator which computes all this for me. It tells me that if there are 30 people, the probability jumps to over 70%. If there are 35 people, the probability jumps to over 81%. And if there are 40 people, the probability jumps to over 89%. So that is my solution to what I think is a very interesting math challenge. Thank you for watching this solution video.